A model can generally be thought of as having parameters that one wants to vary and some standard analyses that are wanted for each variation. The common types of parameters that users wish to vary include material properties, position of parts, orientation of parts and sizes or distortion of part shapes. We will demonstrate parametrics using the same solved quick start model as in Part 1. From the menu bar, select Solution Define Parametrics, Parametric Setup. The Parametric Setup dialog will open. Left-click the Create button in the lower left corner of the dialog. The Parameter Editor dialog will open. The default parameter type, Geometry Displacement, is what we will be using, so we will not change this. However, you may wish to rummage through the list to see the various parameters that can be set up. Edit the name, steps, and target point as shown here. Left-click the Select Geometry button. The dialog will close while you select the geometry. Either use Region or Object Selection and left-click once to select the ring. When the ring highlights green, right-click on the End selection. The dialog will reappear, and the ring will appear green to indicate it is the geometry to which the parameter will apply. Left-click the Apply Create button. The Parametric Setup dialog will appear again, but with your defined parameter now in the Parameters Defined list. The geometry corresponding to the selected parameter, the only one in this case, is highlighted green. To visualize the total parametric setup, left-click the two arrows highlighted below to toggle the display to the fully expanded dialog. The defined outputs don't appear under post-processing here. That list is for the temporary outputs that can be obtained from the Analysis menu. From the menu bar, select Analysis, then Force, then Coulomb Force on Region. The dialog will disappear, and the command line will prompt you to select Geometry. Select the ring, right-click to End Selection. The dialog will reappear, and the post-processing will show Force on the region. Left-click the Close button. To clear all the existing outputs, select Analysis, then Output Manager, and click the Clear All Data button. Click the Yes button when asked to confirm. Save this model, and from the menu bar, select Run Parametrics from the solution. A dialog will open prompting you for a database name to save the results in. It is recommended to modify the name to ELECTRO Quick Start. The solver will now iterate through all the requested parametric variations. When it is done, the final parametric table will appear. Left-click the Graph Results button. Set the Graph Results dialog as shown. Left-click the Graph Results button. A graph will appear showing the force versus the parametric step number. Left-click the Close button for all open dialog boxes. To analyze the defined outputs, select Analysis, then Output Manager from menu bar. In the pop-up dialog, select the Plots tab and set the animation slider to the fast end. Left-click the Animate button. ELECTRO will cycle through displaying your plots. Press the Escape button on your keyboard to stop the animation. When you have settings you like for animation, you can use the Save Animation button to make a video file. To view plots from individual analysis, set the step number, then left-click the Show Step button. You can also animate the 2D graph window. Select the 2D Graphs tab and set the animation slider to the fast end. Left-click the Animate button. ELECTRO will cycle through displaying your graphs. Press the Escape button on your keyboard to stop the animation. Scripting via the API is the other major way of automating the use of integrated software. Scripting takes more setup time than parametrics, but offers much more power and has more potential for long-term use. While parametrics are restricted to studying systematic variation of existing model parameters, scripting offers many more possibilities. This demonstration script will duplicate what the parametric in the first part of this sample did and produce a table and plot of E versus displacement. To run a script for the first time on your computer, some extra setup will need to be done. Close ELECTRO and using Windows Explorer navigate to the folder when ELECTRO is installed. Right-click on the file iest.exe. In the pop-up menu, click Run as Administrator. ELECTRO will open in a special mode that sets up the Windows registry for external scripting control. Close ELECTRO. Now start ELECTRO and left-click the Run ELECTRO Sample button on the Excel sheet. While the macro runs, both ELECTRO and Excel will be locked. The macro will move the ring by the number of positions and total displacement given in the spreadsheet, solve, and report the electric field at the specified position. When the macro has been completed, the spreadsheet will show a data table and plot of the E field magnitude versus ring displacement. The results will be the same as what was found for the same positions with the parametric example earlier. To compare with the E field values at this location computed with parametrics, select the Parametric Results button from the Analysis menu. Move the dialog side by side with the Excel data columns. The E magnitude at each position should report the same. This example shows a very quick, limited use of scripting for direct comparison with parametrics. Similar targeted tools can be developed as scripts, but much more ambitious custom design tools, even involving the creation of the model, can be created.